Welcome everybody to Sustainable River Basin Management Module 3.1 Part 2. Last time we were talking about how to measure water scarcity and how to assess water scarcity, and we started looking into some of the indices which were developed. I want to continue this in this module and complete it in this module. The next that I want to show you is the Physical and Economic Water Scarcity Index. What does it mean? It is including the country's water infrastructure, which means also water infrastructure dealing with desalination of water. It measures water availability. It also includes the recycled water by limiting the measurements of water demand to the consumptive use instead of taking the total withdrawals as other indices have been doing. It also measures the adaptive capacity of a country by assessing the potential for infrastructure development in the water sector and the efficiency in the improvements of the infrastructure. That index was developed by the International Water Management Institute in 2008, and you can get more information from that institute. It classifies countries that are predicted to be either in one or the other of the two categories. The first category is called economically water scarce. So what does it mean, economically water scarce? It means that that country is unable to meet the future water demand without investment in water infrastructure and without investment in water efficiency. And it means that less than 25% of the water resources of that country are utilized. So this is one of the groups, and the second of the second division is called physically water scarce, and this means that a country is unable to meet its future demand even if it is able to invest in water infrastructure. And this is because more than 75% of the water resources have been utilized. The water resources are in an acute environmental degradation state. The groundwater resources have been diminishing, and water allocations are in support of certain and some sectors over others. So those are the two differentiations. One is economical and the other physical. Physical in the sense of having reached the hydrologically available maximum in a particular country. Now let's look at a recent map of the Physical and Economic Water Scarcity Index. This was produced in 2012. You can look up maps of 2008, and you see slight changes in that. Now what you can see here is the green color for little or no water scarcity, and there are several regions where this applies. Except on the African continent, where we have water scarcity in both ways. And we have the two blue colors here indicating physical water scarcity or approaching physical water scarcity. And what we see is that major parts here fall under this category. This means that the water resources have been fully exploited or heavily degraded to a level that even economic inputs or investments in the water infrastructure will not be able to improve on water scarcity. And then we have the dark blue here, which gives us the economic water scarcity group. And we see that large parts of the African continent are classified as economically water scarce, which means that there's large potential for water infrastructure investments. This is where probably most of the budgets will be going to in the near future on water development in all scales. But we also can see this in this part here in Asia, where there's potential, where water investments in the water sector still would bring a relief to water scarcity. And then there are some parts which are not estimated and cannot be represented here. Now, we have been looking into the water aspects from a hydrological component, from a hydrological point of view, from a country's capability to manage its water resources, but it still lacks one of the components which are quite important when we want to be comprehensive, when we also talk about sustainability. And for that reason, a so-called water poverty index was developed. And this is an attempt to take into account the role of income and wealth when we assess water scarcity. So it includes the level of access to water. It includes water quantity, quality, and also the water variability. It includes the components of water use for domestic purposes, for food and for productive purposes. It includes also the capacity for water management and also includes environmental aspects. So this is a trial to be entirely comprehensive along the sustainability scale. That index is expressed as a score ranging from 1 to 100, whereby 100 means the highest, the best situation. There are major restrictions to this water poverty index. It's a very complex approach, and it's more suited for analysis at local scale, where data may be more easily available or can be collected specifically for this purpose, rather than on a national level. But I want to show you the inputs, an example matrix for this water poverty index. This shows us the components here, such as the resources, access, capacity, use, environment, those which I mentioned before. And then we have sub-indexes, water quality, water stress, and so on, informational capacity, and so on. And then we have indicators for each of these major components, which are the actual data, which have to be grouped accordingly and then transformed into an index to form the water poverty index. So we see that this is where it becomes very challenging to bring all these data together and to bring the data together in a way that you can compare one region with another region. If you are not able to collect all of the data for all of the areas that you want to compare against each other, that may be difficult. Now let's look into examples of the water poverty index. It has been calculated at country level, and this shows us a list of the water poverty index in 2002 for some countries, and we find India here on the scale. And we have that same information put into a map, which you may find easier readable, where we have the highest scoring, a classification here, highest scoring, so to say, from above about 68, and we have the lowest scoring below 48%, or 48 points. Take points here. What is interesting here is that there are a very few countries or regions which are scoring quite high, and there are many parts, even in Europe, or where we, including in Europe, where the scoring is only in the middle ranges here, or middle to high ranges, and then we have many regions where the scoring is very low or low to middle. Yeah. But there are parts where we would think that the range may be different, because maybe the economical power potentials are lower in some of these regions, which still putting it into a water poverty scale analysis actually score quite well. Now, a more typical way of visualizing the water poverty index, which also is more helpful from a decision-taking point of view, is the spider diagram. And this is an example bringing together some of the countries, Japan, Korea, China, USA. And we have here on each of these axes one of the components which make up the water poverty index, and then the different lines here correspond to the countries which I just mentioned, and then we can see where the strengths and the weaknesses are in the water sector in each of the countries. We can do this for catchments and compare catchments with each other. We can take this also as a monitoring criteria as a baseline to start with or start from, and after some years of interventions we could develop or calculate our water poverty index again and see whether we have achieved changes, for instance, in capacity or access or in environment, whatever the most needed sector is in terms of to improve on water scarcity in a particular area. So this is very useful for planning, very useful for monitoring, and for setting priorities in improving the water situation in a particular area. Now, the last of these indicators or indices which I wanted to present to you is the Basic Human Needs Index. That is based on the use of water instead of water availability. I can make water available in a constrained way, and then all you have available is what you can use, because I've been restricting it, or somebody has been restricting it. Or you can make water abundant, and then it's not constrained by the availability, but the way I am consuming it, or the techniques, or the way I perceive how water should be used. So to differentiate between those two, the constrained water use and the abundant and available the water use under abundant or water available situations, that Basic Human Needs Index becomes important. It is the amount of water that a person needs for basic water requirements, and what we mean by basic water requirements is drinking, cooking, bathing, sanitation and hygiene. And there is a threshold that was defined by the WHO, the World Health Organization, which is said to be about 50 liters per person per day. Some countries have set their own thresholds, but this is generally agreed basic threshold used at global scale. And this is useful to estimate number of countries where the average domestic water use is below that threshold. This is to point to situations which need attention and need improvements. It is being used at country level usually, and for that reason it does not depict water scarcity as such, because it's not looking into the industrial uses or the agricultural uses or whatever the other water utilizations are in a particular country. And it also does not depict water quality aspects. Now, the basic human needs index applied to countries. This is from the Human Development Report 2006. You could go to this database and access more information for your own research on this matter. Just have a look at where India is positioning in this report at about just above 80 liters per person per day. So compared to what globally a person's been using is India in the lower ranks here. But again, what human need is, it's been defined by what I've been saying before: cooking, drinking, and so on. And this personal average water use here certainly accounts for many other uses of that person on a day, and not just for the basic needs. So again, this maybe looked at it from a critical development point of view, but also could be looked at from a different angle, from an efficiency point of view, in what actually is basic need, what should be provided and has to be provided, and what is above or outside the basic needs and accounted for here in this case. Now, stepping out of this water scarcity as such, and taking this into a broader perspective of environmental performance or environmental sustainability, there has been an attempt to develop such indices to measure all these dimensions from not only the water availability perspective. And one of the examples I want to present to you here as well, the so-called Environmental Performance Index, which was developed jointly and is presented as a toolbox on this university's webpage. It basically divides our environmental components into two parts. One, the environmental health, which measures the protection of human health from environmental harm. This is one way. This is the human-centered perspective. And it combines this with the ecosystem vitality, which is the measure of an ecosystem protection and resources management. So this is the functioning of an ecosystem and how well it's been managed. And the data which are taken into this index are usually derived from national census data. So there's a trial to only use such data which are usually being collected by the countries census, or the authorities responsible for census data collection. Now, this environmental performance index is scaled like this. We have 0 to 100 score or percentage. The lowest 0 is the lowest benchmark, and 100 is the top benchmark, and then this has been stretched along the international range. So this means that this scale is changing depending on how the international range is. If we overall do better, then that range will move up, or if we overall do worse, then the top benchmark will be shifting towards the lower levels. And then we have a differentiation between worse performance and better performance of countries. Now, this is now put into, we have now, the way this has been presented, we have the ecosystem vitality on one side here, this color part half, and this one the environmental health. And this is then subdivided into categories, and for each of those subcategories, indicators or data are collected and then taken into this index. So it's, for instance, the health impacts, air quality, water and sanitation on one side, which correspond to the environmental health, and to ecosystem vitality. We have climate and energy, we have biodiversity and habitat, we have fishery, we have forest, agriculture, the water resources. And then we have those different components for which each country should have some data available, which could enable us to convert it into an index and compare one with the other. Now, let's look into just two examples. This is the case of India in the year 2014, last year. And we have here the subcategories, which I just read out here, only a part. I just cut that table. And we have here the overall score of India here, scoring about 31% points. And if we go back, it would perform somewhere here along the scale. And we also can see in this table the long-term changes, the change compared to 10 years ago. And we can see that, for instance, in the case of air quality, the situation has deteriorated, whereas in the part of water and sanitation, a lot has happened. The changes are along the positive scale. The same to agriculture and the same to health impacts, where we see positive changes. Now, this is very useful, as with the case of the water poverty index in a spider diagram. It is quite useful to identify individual fields where interventions are required, where changes are necessary, and where changes can be made visible also, where we can monitor the changes to the better or monitor the changes to the worse in both directions. Now, just to provide a contrast, I've picked another country as an example, Germany, also the year of 2014. And what you can see here is that the overall score is high, about 80% here. And but what you also see is that only a few changes have taken place, where the situation has become or has decreased is in fishery, for instance, where the situation has improved is in agriculture. And a lot was done in the agricultural field through subsidy schemes where less of pollution is taking place, for instance. But we also see improvements in air quality and also in health impacts. So this is a good way or useful way for decision taking, also for long-term comparison. So on this I want to stop and move into a new subject next time I see you again.